Wow, cancel.
Here this is the overhanging on both sides. Here overhanging, which is the combination of simply supported beam and cantilever beam. Okay. Then first of all, A, B, C, D, and E. Okay. First, find out reactive force at the point A and B. Here, this portion, if you see, this is a simply supported beam, and this portion here, this portion, and also this portion, that is cantilever. Overhanging beam means that beam which is extended beyond the supports. Overhanging on both sides, overhanging on left side, overhanging on right side. That is the type of overhanging. But this is the overhanging on both sides. Okay. On both sides, if you see the cantilever beam and in middle, that is simply supported beam, means that overhanging beam which is combination of cantilever beam and simply supported beam. Then first step to calculate reactive force at fixed ray endpoint A and B. Okay. Then first find out according to equilibrium condition, summation of y that is equal to 0. Summation Fy that is equal to 0. Then first, the first force is 1000 Ra plus Rb. We take algebraic sum of all vertical forces here. Second force, if you take any force, downward force is negative, upward force is positive. Ra plus Rb, then this is downward, then this is 1000, that is equal to 0. Okay. Ra plus Rb, then Ra plus Rb, then you take sum, that is very simple. 1500 plus 2400 plus 1000. Okay. 4900. 4900, that is equal to 0. Ra plus Rb, that is equal to 4900. Consider equation number 1. Okay. Then here we take moment, algebraic sum of all moment above point A. Okay, that is second condition. The first condition is summation of y that is equal to 0. Okay, then we take algebraic sum of all vertical forces. Downward force is considered negative, upward force is considered positive. Then first we get equation Ra plus Rb that is equal to 4900. Considering equation 1. Considering as equation 1. Then applying second equilibrium condition, summation EMA that is equal to 0. What is meaning of summation EMA that is equal to 0? We take algebraic sum of moment of all forces about fixed point A. Okay. We can also take point B, doesn't matter. We can take algebraic sum of moment of all forces about point B also. Okay. Then clockwise direction is taken as positive and anti-clockwise is taken as negative. That is sign convention. Anti-clockwise negative, clockwise positive. Okay. Then here, first we take moment. This is clockwise moment 1500 into T plus 7, that is 10. Second, that is minus RB, reactive force at point B, RB, reactive force at point A, that is RA. Then RB into total distance 7, then this plus 2400 into distance, this distance is 4. Okay. Then this also taken anti-clockwise minus 1000 into minus 1000 into distance up to point A, that is 2. Okay. Then first 1000 you take 0 minus 7 RB plus, we just do the calculation, 2400 into 4, 9600 minus 2000, that is equal to 0. We take addition 1500 plus 9600 minus 2000 minus 7 RB 22,600, that is equal to 0. Then 7 RB, that is equal to RB, that is equal to divided by, then here do the calculation, divided by 7. 322.57 kilo. Okay, that is the answer. Then here, once we get the value of RB, then put this value in the above equation 1. Then we get RA plus 322.57, that is equal to 4900. Then RA, that is equal to 4900 minus 328.57. Then RA, that is equal to 1671.43 kilonewton. Okay, this is the value of the RA. Okay. Once we find out the values of RB and RA, then calculate shear force. Means we calculate SF, then calculate DM, and according to values of SF and DM, then draw the SFD as well as DM. Okay. This is RA 1671.43 kilonewton, and this is the value of RB 3228.57 kilonewton. Okay, then just you can write that value here 1671.43 kilonewton kilonewton. Then here RB 322.57 kilonewton. Okay. Once we find out the values of RA and RB, then step second SF calculation. SF calculation. Positive SF, negative SF. Okay, that is sign convention regarding SF. Then here first the shear force calculation for all values of shear force. We can start from right to left side, okay, of the beam. This is very simple procedure. First, we take shear force, and each point load is considered as a section, and it has a two side of that section, either left side or right side. Here, the first point load and the point is 1,500 kilonewton. Second, this is reactive force at fixed point R. Third, fourth, and fifth. Okay. And it has two sides, left side, right side, left side, right, left, right, left, right, left. Okay, means that whatever point load acting on the beam, then you can first consider as a section for that point load. Then it has a two side of that section, left side and right side. Okay, then calculation of shear force always start from right side to left side of the beam. Then first we take shear force at the point E, right side. It has no load on the right side of the point E, and always consider 0. Shear force at the point E, left side 0, downward, right side downward is positive, 1,500. Shear force next. Shear force at the point B, right side, 1,500 kilonewton. This force is continued at the right side of the point B, because in between portion BE, it has no load. This force will be carried. This force will be carried forward at the right side of the point B, because in between portion BE, there is no load. Okay. Then here, shear force at the point B, left side, this, then upward direction, right side, that is negative, the value is 328.57. Then just do the calculation. This is the 1,500 minus 328.57. Then value will get minus 728.57. Okay, this is the value. Then once we find out shear force at the B on left side, then this value will be continued at the right side of the point C. Shear force at the point C, right side. In between portion CD, it has no load again, and that's why this load will be continuing at the right side of the point C or carry forward. Then shear force at the point C left side minus 1728.57. Then this downward is positive plus 2400. Then we just do the calculation. Then minus 1728.57 plus 2400. 671.43 kilonewton. Okay, shear force at the point C on left side. This force will be continued. This force of load will be continuing at the right side of the point A. Shear force 671.43 kilonewton. Okay. Then shear force at the point A, left side 671.43. Then upward force upward is negative. The value will be 1671.42. Okay. Then you just do the calculation. This is very simple calculation. 171.40 minus 1671.40 minus 1000 kilonewton. Then this force will be continued at right side of the point B minus 1000 kilonewton. Shear force at the point B on left side downward is positive minus this force that will be 0. Okay. This is a calculation regarding all the values of shear force. Then this is first, I will repeat once again. Here, first we calculate shear force at the point E on right side. Then it has no force on the right side of the point E, 0. Calculation will start from right to left side. Okay. Shear force at the point E on left side, just 0. Then downward is positive 1500, that is equal to 1500 kilonewton. Okay, we take right side in the sign convention always through the beam. Okay, then shear force at the point B, the right side, this force will be continued 1500 kilonewton. This force will be continued at the right side of the point B, because in between portion BE there will be no load, and that's why that force or load will continue at the right side of the point B. Clear? Then shear force at the point B on left side, then 1500, then upward force in the right side is negative, then minus 1728.57 kilonewton. Then shear force again in the portion CD, it has no load. This shear force will be continued at the right side of the point C, minus 1728.57 kilonewton. Then shear force at the point C on left side. Then downward is positive. Then 671.43 kilonewton. Then again this force or load will continue at the point A on right side, because in between portion AC it has no load. Shear force at the point A right side. Then again upward force at the point A, shear force at the point A on left side, upward is negative. Then finally you will get minus 1000 kilonewton. Again it has no load, at the right side of the point B. This will continue. Shear force at the point B on right side minus 1000 kilonewton. Then shear force at the point D on left side. Then downward force is positive. 1000 minus 1000, that will be equal to 0. Your calculation for all values of shear force will be correct, because at the end shear force at the end point E and D will be 0. Okay? And that's why your calculation for shear force will be correct. Then third step, bending moment. Calculation of BM. Step EM calculation. BM at the point E. Bending moment at the free end point, that will be equal to 0. Bending moment at free end point always equal to 0. Always remember, that is very important note. Bending moment at free end point of the beam, any type of beam, either cantilever or overhanging, always equal to 0. Bending moment at point E and as well as bending moment at point D will be 0, because it is a free point. Okay. Then remaining point ACD, bending moment at the point D. Here sign convention is, that is negative bending moment, hogging, that is positive bending moment. Hogging means negative bending moment, that is the anti-clockwise direction. And sagging means, sagging means positive bending moment, and hogging means negative bending moment. Then here, bending moment at the point B. Then here this force downward minus 5000. That is hogging bending moment. Distance is 3. 1500 kilonewton. Bending moment at the point A. Here we take, because it is a simply due to simplicity, we can take point A and B. Okay, because you can easily calculate the values of bending moment at point B as well as at point A. That's why we take this side and this side. Bending moment at the point A, that is negative bending moment 1000 into distance 2 minus 2000 kilonewton. Then bending moment at the point C. Okay. You can take calculation for bending moment at the point C from this side or this side, doesn't matter. Okay. You take this side minus 1000 into distance is 4 plus 2, that is 6. Then this will rotate anti-clockwise, that is positive 1671.43 into distance is 4. Okay. Here there are only two forces, this side as well as this. Then minus 1000, minus 1000 into 6, that is minus 6000, plus we just do the calculation. 1671.43 into 4, 6685.72. Just do the calculation. Minus 6000 plus 6685.72 685.72 kilonewton into meter. Okay, that is the value. Then once we find out the value of bending moment at point C, then here all the values of BM is done here. Bending moment at free end point E as well as D will be equal to 0. Bending moment at point B minus 4500. Bending moment at point A minus 1000 to minus 2000 to bending moment at the point C minus 1000 into 6 plus 167.48 into 4. Then final value will get 685.72 kilonewton into meter. Okay. Then here, this is a calculation for SF and BM. And this is simple diagram, means all the all the forces which are acting on the beam. That type of force is point load, means to draw SFD and BMD of overhanging beam, which is subjected to the point load. Okay. In the figure, if you see the figure, all the forces that are point loads. Then I will repeat once again what is the procedure for solving such a kind of problem, particularly in overhanging beam. In the first step, we calculate reactive force, that is RA and RB. According to equilibrium condition, there will be applied two conditions: summation of y that is equal to 0 and summation m that is equal to 0. Then here we take summation of y that is equal to 0. Algebraic sum of all vertical forces which are acting on the beam must be equal to 0. Then we get the one equation that will be considering as equation 1. Then in the second equilibrium condition, apply summation of y that is equal to 0. We take any one fixed point. We take algebraic moment of all forces about any fixed point. Here there are two fixed points A and B. We take either A or B. Okay. Then we get two values of forces, that is reactive forces, that is RA and RB. Once we find out the values of RA and RB, once we get the reaction at the fixed end point A and B, then in the second step, to calculate SF, means SF calculation according to sign convention, positive SF and negative SF. Then calculation always start from right side of the beam to the left side of the beam. Okay, and each point load is considered as a section, and it has a two side of that section, left side as well as right side. Then here shear force at the point E0, shear force on right side, shear force at the point E on left side. Similarly, we calculate shear force at the point B, C, A and D. Okay. Then once we get all the values of shear force at different points A, B, C, D, E, then to calculate BM, bending moment. Bending moment calculation is very simple according to sign convention: negative bending moment and positive bending moment. Then here bending moment calculation, bending moment at point E, that will be 0. Bending moment at point D, that will be 0. Why it will be 0? Because bending moment at free end point of any type of beam will be always 0. Bending moment at free end point of any type of beam always equal to 0. Okay. Bending moment here, there will be two points, that is free point D and E, and bending moment at point D and E will be 0. Then bending moment at point B minus 1500 into 3 then we can draw the SFD and BMD. This is very simple process. Then I will just draw the SFD. First draw the reference line or datum line. Then according to value, shear force at the point B, left side 0. Then here the force is downward. Then if the point load is downward, the value is minus. Minus means the load goes downward direction. All the positive values are plotted above the baseline, whereas all the negative values are plotted below the baseline. Here, shear force at the point D on left side 0, left side 0. Then shear force at the point D on right side minus 1000 kilonewton, negative sign. That value is minus. That value is minus. Minus means the arrow, the direction of force is downward. It will go downward direction. Again in the portion A, no load, draw the horizontal straight line. The force is upward at the left side. This is also negative. Then the force goes in upward direction like this. Shear force at the point A on right side. 671.43. Again in the portion, no force. It will goes downward direction at the point C, right side, negative value. Then again in the portion, no load. Again it will goes upward. Again in the portion, no load. Again it will goes downward. This is negative. This is positive. This is negative. This is positive. This is SFD in kilometer. Okay. That will be equal to 0. This is simple drawing for SFD. Then similarly we calculate BM. Draw the data line. Then here downward force, point load it has no effect. Then bending moment at the point B 0. Then in between DA, bending moment at the point A, the value will be negative. It will go downward direction. In between DA, no load means inclined straight line. That value will be negative. Then again, point load, no effect. Again, no load in the portion AC, but value will be positive. Then again, it will go negative. Again, like this. Means this is BMD in kilonewton into meter. At the point B, bending moment at the point B 0. Okay. Then in the portion AD, no load. Then bending moment is inclined straight line downward. Why? Because bending moment at the point A is negative value. Then again it will go in upward direction. Again no effect in BMD. In the portion AC, again inclined straight line, that value at the point C is positive. All the positive values are plotted above the baseline, whereas all the negative values are plotted below the baseline. Then this downward force, again no effect in BMD. In the portion CD, the value at the point, bending moment at the point B is negative. And in the portion CD, no load. No load means inclined straight line. Then again, bending moment at the point E is 0. In the portion B, again, no load, then draw the inclined straight line. Okay, this is negative, this is positive, this is also negative. This is simple BMD. Okay. This is the easiest way to draw SFD and BMD. You just follow some simple rules for drawing SFD and BMD. And according to